Hi everyone, for today's lesson, we are going to practice using our properties of rhombuses and rectangles. Before we get started, please make sure that you have some colors with you, something to write with, and that you've already completed the properties of rhombuses and rectangles vocab video lesson. So please make sure that you have this finished. You might also want to have a calculator depending on if some of the calculations are a little too much for you. We do work with some big numbers in this lesson. So anyways, let's go ahead and recap our vocab video lesson. In our vocab video lesson, we learned about the properties of rhombuses and rectangles. And we learned that a rhombus and a rectangle is a very special parallelogram. So a rectangle, let's go ahead and review rectangle. A rectangle, I don't know why it's always crooked, so just forgive me. Okay, so a rectangle is a parallelogram, which means that it has all of the properties of a parallelogram. Opposite sides being parallel, opposite sides are congruent, opposite angles are congruent, consecutive interior angles are supplementary. So that means going all the way around any angle that touches each other or share a common side, they add to equal 180 degrees, and the diagonals bisect each other. But because a rectangle is a parallelogram with 4 right angles, as a consequence, there ends up being extra properties that comes with it. Not only are all angles congruent because they are all right angles, what you end up finding is that the diagonals are congruent as well. So not only do the diagonals bisect each other, but in a rectangle, the diagonals are congruent. And as a result, what you'll end up finding, and this is for all parallelograms, but this is something that I want to emphasize here, in all parallelograms, the diagonals intersect to form 2 pairs of congruent triangles. But what's special about a rectangle is not only are those triangles congruent, they are isosceles, which means that your base angles are always going to be congruent. So not only do you have alternate interior angles being congruent, you have base angles of the triangles also being congruent. So that is something I want you guys to keep in mind as you are trying to find missing angle measures. The other shape that we had was a rhombus. And a rhombus also has all of the properties of a parallelogram, meaning opposite sides are going to be parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. But all of those are the same. But what makes a rhombus a special parallelogram is that all of the sides are congruent, 4 congruent sides. And as a consequence of there being 4 congruent sides, extra properties exist. And they exist with the diagonals. So what's really cool about the properties of a rhombus is that the diagonals will bisect the opposite angles. So it'll cut your opposite angles in half. The other thing that's really cool is that the diagonals are perpendicular. So we call the diagonals perpendicular bisectors. And that's because not only do they bisect each other, they bisect and create a right angle. So we have ourselves diagonals bisect opposite angles, they bisect each other, and they're perpendicular. And what you end up finding is that we end up having not just 2 pairs of congruent triangles, but all of the triangles are congruent and they are right triangles. So you might end up using the Pythagorean theorem for some problems, and I just want you guys to be aware of that. So those are all of the properties of rectangles and rhombuses, and we are going to be using those properties in this lesson. So let's go ahead and start with example number 1. In example number 1, what this is asking us to do is it's asking us to find, so it's saying that the diagonals of a rhombus, so we are talking about a rhombus. Always emphasize what shape you're talking about and mark up what you know. I know that a rhombus has 4 congruent sides, so I'm going to immediately mark that up. So we are told that the diagonals of rhombus WXYZ intersect at point V. And we have the measure of angle XZY, so here is XZY, is 34 degrees. That's already marked in. And we're told that WV, which is half of one of the diagonals, is equal to 7. So now using this information, we want to find the indicated measure. So letter A is asking us to find the measure of angle WZV. So let's go ahead and identify where WZV is. That is this angle right here. And one of the things that we know about a rhombus is that the diagonals bisect the opposite angles. And what that means is that WZV has to also be 34 degrees. So I'm going to write down 34 degrees. The measure of angle XZY, so here is XZY. We already know what that is. I guess that was already given to us. That was 34 degrees. And then WY. So we know that diagonals bisect each other. So W to Y, we know that V to Y has to also be 7. And 7 plus 7 is 14. All right, let's go ahead and look at example number 2. In example number 2, we want to determine the measure of the numbered angles in each rhombus. So we're talking about a rhombus here. I cannot emphasize enough, it's really important to know what shape you're working with. And we know that in a rhombus, all sides are congruent, and we know that the angles have been bisected. So in order for us to find the measure of angle 1, that's going to be really easy. Then we know the diagonals bisect each other. So that is going to, measure of angle 1 is going to equal 35 degrees. So now what we want to do is we want to find the measure of angle 2. And there are a lot of approaches for finding the measure of angle 2. So what you would want to do is we would want to find what this whole big angle is. That big angle is going to be equal to 35 plus 35, and that is equal to 70 degrees. So this big angle is 70 degrees. Now we're going to be using that property of parallelograms that says that consecutive angles are supplementary. So this big angle, the purple angle with the pink angle, they are supplementary. So this purple angle is going to be 180 minus 70, which is 110 degrees. 110 degrees is the big, huge purple angle, but it is still not the measure of angle 2. The measure of angle 2 is going to be half that because remember that the diagonals bisect the opposite angles. So that means that if this big, huge purple angle is 110, the measure of angle 2 has to equal 110 cut in half. And half of 110 is 55 degrees. Let's go ahead and look at letter B. For letter B, once again, we know this is a rhombus, so I always mark up that all of the sides are congruent, and we're also working with those angles again. So I know that this angle right here is 12 degrees, and I need to find the measure of angle 1 and then the measure of angle 2. So the measure of angle 1 is this piece right here, and the measure of angle 2 is this piece right here. So angle 2, I actually think is the easiest to identify first, and that's because we're going to be working with the property that the diagonals of a rhombus are perpendicular. Perpendicular lines form right angles. So the measure of angle 2 is 90 degrees, and I'm going to mark that up with a 90-degree angle symbol. So we know that one right away. The measure of angle 1 is going to require very similar steps to what we did in letter A, and that's going to require some analysis. So there's a few approaches that you can do. One approach is to work with triangles. So I didn't work with triangles last time, but I want to show a different approach just so that you guys are all aware. We could still take this and make 12 plus 12 is 24, and then 24 minus 180, and then take that answer and cut it in half, and that's going to equal the measure of angle 1. Or you can use the fact that what we have here are opposite sides being congruent, opposite angles are congruent as well. And we can work with the fact that we have ourselves a right triangle here. So I'm going to go ahead and emphasize the fact that we have ourselves a right triangle. And we know that this angle right here is 12 degrees. So if I'm working with this right triangle, and I know that this angle right here is 12 degrees, then that means that I can find this other angle by using the 180-degree rule. Or I can also use the corollary to the triangle sum theorem that says that this angle 1, has to be complementary with the other acute angle. So I can actually go 90 minus 12, which is going to be equal to 78 degrees. So the measure of angle 1 is equal to 78 degrees. All right, let's go ahead and look at example number 3. In example number 3, they're telling us that WXYZ is a rhombus. Solve for Y. So in this problem, we know that all of the sides are congruent. And if we know that one side is 2y plus 3 and the other side is 5y minus 6, we're going to set 2y plus 3 equal to 5y minus 6. I'm going to subtract 2y on both sides. I'm going to add 6 on both sides, and we find that 9 is equal to 3y. Dividing both sides by 3, we find that y is equal to 3. And there's our answer. Let's go ahead and look at number 4. So in example number 4, we're told that the figure is a rectangle. So if it's a rectangle, I'm going to immediately mark up my angles. Now remember that my angles are 4 right angles, and we want to find all of the angles that are 30 degrees. So we're going to mark that up. Now remember, we know that the diagonals are they not just bisect each other, we know that they are congruent. And what that uniquely creates is it creates isosceles triangles that are congruent to each other. So I have 2 pairs of congruent triangles. I also know that opposite sides are congruent with each other. So I'm going to be working with this idea that we have 2 isosceles congruent triangles. I know they're congruent by side, side, side. And we did a lot of that earlier this year. So if I know that this base angle is 30 degrees, that means that this base angle has to be 30 degrees. And I know that alternate interior angles are congruent. So that means that this base angle is 30 degrees and this base angle is 30 degrees. I'm just going to remind you really quick, in an isosceles triangle, there are 2 properties. Number 1, there is at least 2 congruent sides. And number 2, there is at least 2 congruent angles. And typically those angles are what we call the base angles. So those are all of the angles that are 30 degrees. Next, we want to find all of the angles at point E. So I know that in this triangle right here, I know 2 of the angles. They're 30 and 30. And so if I wanted to find what this missing angle is, all I'm going to do is use my 180-degree rule. So I'm going to take 180 minus 30 minus 30. 180 minus 30, and then minus 30 again, is equal to 120 degrees. So that makes this angle, which is a vertical angle, 120 degrees. The last property that I'm going to be working with is a linear pair. And I know that 120 degrees and this angle over here is going to together form a linear pair, together form a line. I can also view this as an exterior angle, and this exterior angle is the sum of the 2 non-adjacent interiors, making this 60 degrees. That's another approach. But if you were just to go 180 minus 120, that's going to equal 60 degrees. So there's a lot of approaches. And then I'm going to work with vertical angles. That's going to say that this angle over here is 60 degrees as well. So those are all of the angles at point E. So this is where we get to bring back everything that we've already learned and kind of jumble up all of these properties together, which I find to be very fascinating. Let's go ahead and look at our next page. For example number 5, it says the diagonals of a rectangle. So that word rectangle is not emphasized, so I need you guys to emphasize that word. We are talking about a rectangle. So whenever you see rectangle, immediately mark in those angles. We know that all angles are right angles, so mark those up immediately. If it helps, mark up that the diagonals are congruent as well, because those are those extra properties, and we use those extra properties in rectangles. We're told that the measure of angle RPS is 62 degrees. We're also told that Q to S is 18. So that's the whole diagonal. And I'm going to mark that up, that the whole diagonal is 18. And I would therefore mark up that each piece is 9 and 9, because we know that the diagonals bisect each other or cuts each other in half. So half of 18 I know is 9. And now we're going to find the indicated measures. So we first want to find what the measure of angle QPR is. So let's go ahead and look at where QPR. So here is QPR. So that is this angle right here, QPR. I know that this collectively, angle P is equal to 90 degrees, and a piece of it is 62. So the other piece has to be equal to 90 minus 62. And 90 minus 62 is 28 degrees. So then that means that the measure of angle QPR is 28 degrees. Now we need to find what ST is. And I already marked that up because I already anticipated it. S to T is equal to 9. P to R, remember that the diagonals are congruent. That's part of our extra properties. The diagonals are congruent, so therefore PR is equal to 18. And finally, we want to find the measure of angle PTQ. And we're going to be working with that idea that we have ourselves an isosceles triangle inside of our rectangles. So I know that if this angle QPR is 28 degrees, the other base angle is 28 degrees, and I'm interested in this angle right here. So I'm going to go 180 minus 28 minus 28, and 128 or 180 minus 28 minus 28, that is equal to 124 degrees. And there's our answer. I have 2 U tries, so I'm going to encourage you guys to try those, and we will discuss them the next time I see you in class. And that is the end of today's lesson. If you have any questions over anything that I just showed you, please feel free to email me. Otherwise, I hope you have a wonderful day.